Last time we stopped at example 2.1, right? So of course, I think you know how to do the mathematics and how to calculate this type of questions because you must have done it in your high school. So now here remember that draw a diagram before you do the calculation. This one and for all the unknown sets, just write let something be a symbol and then do a calculations and remember to mark your result in the put a box around your result. Okay, these three things. So today I will go on with sample problem 2.2. Sample problem 2.2 is like this, and so a barge is pulled by two tugboats. The Chinese of these two are this one, and 然后 so we go on with if the resultant of the forces exerted by two forces is directed along the axis of the barge, determine these two things. So remember, in this type of problem, if we see the word determine, that means what do we need to calculate? Okay, determine here. And the tension in each rope if alpha is equal to 45 degrees, and the second is the value of alpha where the tension of rope BC is minimum. Tension here is is a force inside the rope, okay? And BC is this one. Okay, now we go on with doing the calculations. So we go on with part A. So what do we need to know in part A? So the tension in each rope. We have two ropes. We have rope AB and we have rope BC. So what do? We first let the let the tensions in ropes AB and BC be T1 and T2 respectively. So we saw the word here let, and this one respectively 分别啊。So this is AB is this one and BC is this one. If you write the word respectively. Now we have give them symbols or give them variable names. So we have so we draw the diagram. Okay, so we draw a diagram. Of course, in examination, you don't need to write this. No, this is you don't need to write this in exam. I just want to show diagram is cool. So we have T1 here and T2 here. And we have this is 30 degrees and this is 45 degrees. And what do we know is the resultants. The resultant, which is T1 plus T2, is 5 kilonewton, and it is along the axis. Along the axis is this one. So it means T1 plus T2 is this one. Okay. Now, of course, we know that how to add T1 and T2 together, and of course we have two ways. One is by parallelogram, and other is by triangle, right? So let's do it by triangle. And but we don't know how big or how large T1 is. We don't know how large is T2 either. So how can we draw the diagram? We know the resultant. We know the resultant is 5 kilonewton. We know the resultant is 5 kilonewton, so we have 5 kilonewton here. We don't know the magnitudes. We don't know the magnitudes of vectors T1 and T2, but what do we know about T1 and T2? Do we know anything about T1 and T2? We don't know how large they are, but we know the angle or direction, right? So what can we do? So we draw it like this. Because T1 is 30 degrees to the top right hand corner, but we don't know how long should we draw it, right? So we draw in English we call this dashed line. Because we know the angle, we don't know how large it is, but we know the angle. We know the angle, but we don't know how large it is. So we draw a dashed line on the diagram. Next, do we know the angle of T2? Do we know the angle of T2? Yes. So we do the same thing again, and of course, it is 45 degrees. Of course, this is a bit inaccurate, but you know what I mean. So this one is the direction of T2 is going to the bottom right-hand corner. So this is T2. We don't know how long it should be, right? So we have T1 and T2, and of course we know this is this way and this way. We know the angles, but we don't know the magnitudes of T1 and T2. But we know the magnitude of the resultant. So of course I think you know how to calculate T1 and T2 now. Right? So we have 30 degrees here and 45 degrees here. So what's the angle here? What's the angle? What's this angle? 105 degrees. So the rest that I think we can do the rest. And I will give you some time to draw down. So we have this, and it's okay. Any problem with the diagram? Now we go on, and to solve this problem, we simply use the by sine rule. So 5 kilonewton sine 105 degrees is equal to T1 over sine 45 degrees and equal to T2 over sine 30 degrees. I think you have learned this at high school. Okay, so now that of course that and we have T1 is equal to 3.66 kilonewton and T2 equal to 2.59 kilonewton. Any problem with this? So I'll give you some time to. Any problem? Yeah, of course, for if you have a problem that you can ask me now or ask me later. Okay. And here because we have because this here we don't have the angle sign, right? We don't have this 30 degree or 45 degrees. And here we don't need to write them because these are tensions. These are tensions. So and here let me write right here. So if your answer is a tension in a rope or tension in something that you don't need to write down the angle. But for normal forces that you don't know because in a rope that because for a rope that the forces are always in this direction, so we don't need to mark the direction. But for other forces that we need to mark the directions. This is part A. This is part A, and any problem with this? And of course, if you have a question, you can ask it now. And So if we are okay, then we go on to part B. Part B is the value of alpha where tension of, let me show it here. The value of alpha where tension of flow BC is minimum. Minimum is this one. So we don't know the value of alpha, but we will try different values of alpha, and we want to get a value of alpha such that this value, the force in this rope is minimum. Okay. So how should we do this? Now we go on to part B. Now we have what do we know here? That we know the magnitude and the magnitude of resultant 5 kilonewton, and we know the direction of and we know the direction of T1. And what's this degree? What's this angle? Okay, so this is 30 degrees. So we don't know the magnitude, and we don't know the magnitude of T2, and we don't know the angle of T2 either. But we know we want to. But for example, if T2 is equal to, say, T2 is equal to 1 kilonewton, but we don't know the angle, that you will have a T2 will go here or here or here or here, right? If T2 is equal to 1 Newton, that it will go this way, right? If T2 is equal to 2 kilonewton, then that it will go this way or this way or this way, right? So for a minimum for T2 having a minimum, it means that the shortest distance between this point and this line. Okay, because if it is too long, then it means that of course we can have a very long T2. We can have a very long T2, but of course the shortest one is this one, right? So we know that so we draw it here. So what's special about this? What's special about this T2? All right, let me write it here again. Shortest distance between a point and a line. Okay? Now, so what do we have? For example, that actually I drew a circle here, and then it touches T1 here. So what's the angle between T1 and T2? So they have 90 degrees, or we have 90 degrees, or right angle. Okay, we have a right angle between T1 and T2. Of course, that means That means T2 is minimized. Oh, sorry, before I go on, that's of course that the question asks for the value of alpha. So what's the value of alpha here? I think this is on. So alpha is equal to 60 degrees. Okay. So because I asked for alpha, I think the question asks us to determine alpha. So you need to write alpha. Okay. T2 is minimized if the lines of action of T1 and T2 are perpendicular to each other. Okay. So I think in the preparation video that I talk about perpendicular means 互相垂直。So in this fashion, then the alpha is equal to 60 degrees. So let me write it down. I think this is minimized. That's okay. So because of a bit of English here, minimum is 最小值this is and minimize is about okay. So I think if and of course this is minimized. Is this one is I don't know how your English teacher taught you that this is okay. So yeah, a bit of English here. In engineering and science, we like rewriting in this type of passive voice, and usually then in your textbook, that many much of the English is written like this, and minimums 最小值名词minimize 最小化 to make it the minimum. So, is that are there any problems here in this sample problem? So if no problem up to now, that I talk about read about on the next page before we take a break, okay? Now we go to the next page. Here, resolution of a force in the components. Resolution in this book means breaking down. So in this problem, we have on the left is a force F, which is known. And we want to break F down into two forces. One is P and another is Q. So these are unknowns. Okay? So we break down a force into two parts, and these two parts are unknown. Okay. So we have here we have a force F, and we want to break down into a force P and a force Q. F is equal to P plus Q. So P plus Q. The question is how many ways we can break a force down into two components. Many ways, right? We have this is one way, and this is another way, and this is another way, and this is another way. This is also one way, right? We can break a force into two components in many ways. Actually, this is we can say in more formal way that we can say we have infinite number of combinations. Combination 是组合。Infinite number. Okay. So we have many ways, actually infinite number of them. So we have many ways to do this, but we will talk about two cases. And one of them is either P or Q is known. And the second one is lines of action of both P and Q known. We will talk about this. So, and we will talk about these two cases after the break, and you can take time to write them down.